Hello friends, today we are going to discuss 28th problem of chapter 6 HCV part 1. In this question, we have to find out the acceleration of block of mass m, and the friction is acting between the two blocks as well as between the floor and the block. So first of all, we will find out the relation between the acceleration of both the block. Because of the gravity, the small m mass will go down, and as a result, the capital M mass block will move in the horizontal direction. So let's say if the capital M is moving by a distance of x in the rightward direction, then there will be this moves by distance x here, so the pulley will also move, so there will be slack of x in this rope as well as in this rope. So if all the strings are tight, as we know during the motion all the strings remain tight, so this small m mass has to move by distance of 2x. So we can say if the bigger blocks is moving by distance x in the positive x direction, then the small m mass has to move by distance of 2x in downward direction. So the bigger block will have an acceleration a in the horizontal direction, and the small m mass block will have an acceleration of 2a in downward direction. But the small m mass will also move with the bigger block with an acceleration a. So small m mass will have two acceleration in two direction, downward to a horizontal a. So mu2 is the coefficient of friction which is acting between the block and the floor, while mu1 is the coefficient of friction between the blocks. So first we will see the free body diagram of both the blocks. As we can see here, how many forces are acting. First, the tension force is acting on the pulley, and pulley is directly connected to the block, so the tension T is acting on this block in this direction, as well as the same tension is acting in the horizontal direction, and another force is T. So on this block 3T is acting, 2T is horizontal, and one tension is downward direction. And also the normal reaction is acting on the block, which is a pushing force of the block small m. Let's say this is N1. And the gravitation force acting on this block is mg, that is downward, and normal reaction force because of the floor is acting on this block in vertical upward direction. And a friction force is acting on the backward direction, that is F2. And a friction force, because the smaller m mass is moving downward, so the friction force on smaller m mass will act upward. So as an equal and opposite reaction, the friction force on this block will act downward. So on this smaller m, mg is acting downward, and tension is acting upward, and a normal reaction N1 is acting on this in this direction. So the small m mass block have acceleration in downward direction, that is 2a, as well as in horizontal direction. So and also the friction force is acting on this small m mass block in vertical upward direction. So now we will find the equation for the smaller block first. So as we can see here, the block has acceleration a in the horizontal direction, and the block have acceleration 2a in downward direction. So in horizontal direction only N1 is acting, so we know that F is equal to ma, and in horizontal direction the acceleration is a, and total force acting on horizontal direction is n1. So n1 is equal to ma, and in vertical direction three forces are acting, that is mg downward, t and f1 upward. So mg minus t minus f1 is the net downward force acting on this block. So we know that F is equal to ma, and the net force acting on this block is mg minus t minus f1. So F is equal to ma, and here the acceleration is 2a. So for the vertical direction the equation will be mg minus t minus f1 equal to 2ma. So this is the equation second. Now we will find the equation for the bigger block. T is acting here, again T here, T here, normal reaction, mg and 2, friction, again friction F1 because of the smaller block. So in vertical direction there is no motion. It means in vertical direction the forces should be 0. It means vertically upward force is equal to downward forces. So vertically upward force is N2 and downward force acting on the block is F1, mg and T. So N2 is equal to M. So N2 is equal to mg plus T plus F1, where F1 is equal to mu1 into m1. So F1 is the friction force which is acting between the blocks, and that is mu1 n1. So n2 is equal to mg plus t plus f1, and f1 is mu1 n1. And we also know that n1 is n1 is equal to ma, and the friction between the floor and the block is F2, that is mu2 N2. So on substituting the value of N2, the F2 is mu2 in bracket mg plus t plus mu1 N1, and N1 is equal to A1, and we know that the motion of the bigger block is in the horizontal direction. So in horizontal direction, how many forces are acting? The acceleration of the block of mass m is in the horizontal direction, so net force should be in the positive x direction, and that net force is equal to 2t, because the two horizontal tension are acting, and n1 is acting backward and f2 is acting backward. So the net force in the horizontal direction or in the direction of acceleration is 2t minus n1 minus f2, and f is equal to ma. So for horizontal motion, net force is 2t minus n1 minus f2 is equal to ma. So on substituting the value of f2 as mu2 n2, we got our equation number 4. So this is our equation 2t minus ma, where the value of n1 is ma. So on substituting the values of, we got this equation, and now on rearranging the equation will come like this. So t in the bracket 2 minus mu2 is equal to this, and on further rearranging the equation will come like this. So 2 minus mu2 into t minus mu2 capital mg is equal to a in the bracket m plus small m plus mu1 mu2 into m, and we have the equation second, mg minus t minus mu1 ma is equal to 2 ma. On rearranging this equation will become mg minus t is equal to a in the bracket 2m plus mu1 m, and on multiplying this equation by 2 minus mu 2, this will become this. So on solving the equation this and with the equation 6, so we can get our desired acceleration. So thanks for watching this video. If you have any problem in HCV verma's questions, so please leave a comment, and very soon I will make a video on that. So thanks for watching.